Hi guys, I'm Erica Santos and I am here in front of you to discuss and explain how the movements of plates lead to the formation of faults, trenches, volcanoes, rift valleys, and mountain ranges. So before we start, let me ask you something. Did you know what is fault, a trenches, or even a volcanoes or rift valleys, or even a mountain ranges? Think of it, guys. So, if you don't know that, let me introduce to you what is faults, trenches, volcanoes, mountain ranges, and a rift valley. Faults look like waves in a rock layers. They are bends in rock when compression shortens and thickens the crust. It may look like this. A fault is the liner or break in the land. It is formed in the Earth's crust, a brittle response to stress. Generally, the movement of the tectonic plates provide a stress, and rock at the surface break in response to this. And it looks like this. Rift valley. Rift valley forms where the Earth's crust or outermost layer is spreading or splitting apart. Rift valleys are created by tectonic plates or plate tectonics. And it looks like this. Volcanoes. Volcanoes are common along tectonic plate boundaries where oceanic plate sinks beneath other plates. And it looks like this. Trenches. Trenches are steep depressions in the deepest part of the ocean where old ocean crust from our tectonic plates converge and the older dense plate is pushed beneath the lighter plate and deep into the mantle, causing the seafloor and the outermost crust or the lithosphere to bend and form a steep or a V-shaped depression. Trenches. And it looks like this. Mountain ranges. It is a series of mountains or hills ranged in a line and connected by the high grounds. And it looks like this. So now, let's proceed to the discussion. How volcanoes form. This video came from Inspire Education. As the liquid called magma beneath the Earth's crust gets hotter, it rises. It collects a space called a magma chamber just under the surface of the Earth. When the plates of the Earth's crust move and as the magma rises, more and more pressure builds up. Eventually, the magma explodes out of the surface in a volcanic eruption. When it's above the surface of the Earth, the magma is called a lava. When the lava cools down, it hardens to create an extra layer on the Earth's crust. Over time, there are more volcanic eruptions, and each time the lava cools, it builds up the Earth's crust to eventually form a mountain called a volcano. This video came from Geography Lessons. This video will show what happens when two continental plates collide. Suppose there is a subduction zone. When oceanic plates dives below a continental plate, the rest of the plate is also pulled by the slab pull. It may happen that there is both oceanic and continental crust on that plate. Due to the movement of the plate, the continental crust arrives as a subduction zone. Now, two continental plates collide. Both plates are lighted on the lying asthenosphere. As a result, there is little and no subduction. The plates are pushed together and they fold. Sometimes, you can clearly see the rocks has been compressed as a high mountain is created by the folding. This high mountain is told as a orogenic belt. But not only the top of the crust is folded. It may be compared as an ice cube. The larger the ice cube, the more ice there is also underwater. The same applies to the crust. The higher the mountains, the larger valve across in the asthenosphere. The crust of the mountain ranges is very thick, up to a maximum of 80 kilometers. Just like convergence zone in which oceanic plates is involved, they can also be very serious earthquakes as this plate boundary. But because there is no subduction, there is no volcanoes. The African plate and the Indian plate move north against Eurasian plate. Because of this convergent movement, many mountains form from Morocco to India, including the Alps and the Himalayas. These movements to the north started about 60 million years ago. All these mountain ranges, therefore, created in the same era. The mountain formation in this period called the Alpine orogeny. Orogeny means mountain formation, and the term Alpine orogeny means a geological period in which all these mountains originated. Due to erosional weathering, they are dense completely, turned down other mountain ranges, or even disappeared completely. In this video, you've seen with a convergent plate boundary in which only continental plates are involved mountain ranges are created. There are also heavy earthquakes. However, while our convergent plate boundary involving our oceanic plates, there are no volcanoes. Faults. A fault develops where rock structure is broken and forcibly displaces the movement along fault. May be vertical, horizontal, or a combination of both. A normal fault develops from tensional stress. The stress results when a landscape is lifting or pulling apart. Movement along to a normal fault is predominantly vertical, other than the orientation of the fault place may not be perpendicular to the surface. In the animation, quick play to begin as the landscape is extended. Notice that the one side of the fault drops down relative to the other. The fault curve formed from along the uplifted mountain front and eventually erodes away, leaving little surface evidence of the fault. Many landforms can develop from normal faulting, including tilted fault flat mountains, downdrop basins, and uplifted mountain block called horst. A reverse fault develops from compressional stress. Movement along the reverse fault is also predominantly vertical, although in type of reverse fault known as overstress fault, the up-down block overrides the down block in a very low angle. As the landscape is compressed, one side of the fault is pushed up over the other side. Once faulting ends, erosion gradually wears down the uplifted mountain. A strike cliff fault develops from shear, causing one side of the fault to move horizontally past the other. This video is came from Classroom Nation Geography. There are a few different types of fault mountains. The first type is when the continental plate meets a continental plate. Both plates are thick and strong, and one plate will force upward to create a mountain range, and the other plate will be subducted or pushed downwards. This creates a lot of friction, and this friction causes earthquakes. The example is earthquake in Himalayas. This is the example. The next type is when the oceanic crust meets the continental crust. The oceanic will push downwards or subducted or be destroyed. The continental crust will be lifted up slightly, and it's similar to if you put a spatula underneath a slice of pizza. One famous example of this is the Rocky Mountains in USA. As you can see, this is the Rocky Mountains in the USA. The last type is when oceanic crust meets oceanic crust. At this plate boundary, one plate will be subducted and destroyed. This creates heat and magma causing volcanoes. Let's proceed to the Rift Valley and the trenches. I have here a short video clip for you to understand more Rift Valley and the trenches.
Rift Valley Formation. A rift valley is formed as a result of the sinking of a portion of the crust between cracks on the surface of the earth. There are 3 stages in the formation of a rift valley. Stage 1. Layers of rock are subject to tension or stress. Stage 2. Faults or cracks develop in the layers and the central block begins to subside. Stage 3. After subsidence, a depression with steep sides is formed. This is a rift valley. You can make your own rift valley using a long eraser. Take a long eraser and use a pencil to draw fault lines on it. Use a cutter or blade to cut the eraser across the lines drawn earlier. Place the pieces of the long eraser together to make the eraser whole again. Apply a little pressure on the corner pieces and lift the whole eraser above the table. Slowly pull the corner pieces apart and you can see how the land in the middle of fault lines subsides and a rift valley is formed. The Great Rift Valley of Africa is a special physical feature of the Southern Plateau. It is a long, narrow valley formed as a result of vertical cracks that developed because of the movements within the earth. It extends for a total distance of 5,000 kilometers from Lake Malawi through the Red Sea and the Gulf of Aqaba to the Dead Sea in Jordan. Many freshwater lakes like Malawi, Rudolph, Tanganyika are found here.
Ocean floor features. When you imagine the ocean floor, what does it look like? You may be surprised to learn that the bottom of the ocean is a dynamic place with higher mountains and deeper valleys than any found on land. It is a mysterious place too. Some parts of the ocean never receive sunlight, and the pressure of the water is greater than several jumbo jets on top of your body. With such hostile conditions, how do scientists even know what the ocean floor is like? In some ways, gathering information about the ocean floor is similar to learning about space. Sometimes people can travel to the ocean floor in vessels specialized to protect them from the pressure and cold. Just like space, however, many missions are unmanned. Scientists can indirectly determine information about the ocean floor, just like how they use radio and infrared telescopes to observe the sky. One method of indirectly collecting data about the ocean floor involves using sound waves. By reflecting sound off the bottom of the ocean, scientists can map the topography or shape of the ocean floor. If sound waves are sent deeper into the ocean floor, scientists can even learn about its composition. Plate tectonics work to continuously change the topography of the ocean. Just like the plate movement below land masses, the changes may be slow, but they are responsible for the mountains and trenches that comprise the dramatic landscape deep under the water. Earthquakes may even happen underwater, resulting in a giant wave called a tsunami. Divergent boundaries are one example of how plates move in relation to one another. When two ocean plates move away from one another at a divergent plate boundary, magma rises up to create a ridge. The deep crack created in the center of the ridge is called a rift valley. A deep trench is formed where an oceanic plate moves under a continental plate at a subduction zone. At more than 10,800 meters, the Mariana Trench is about 2 kilometers deeper than the height of Mount Everest. Volcanoes also form at subduction zones. When the plate that is pushed downward melts, the magma may rise up to the surface. Volcanoes may also form away from plate boundaries at hotspots. Hotspots are locations where magma rises up through a crack in the crust and reaches the surface. Initially, this forms an underwater mountain called a seamount. The Hawaiian Islands are an example of a series of volcanoes that formed over a hotspot and became large enough to reach above the surface of the water. Some volcanoes may evolve into a guyot over time. Guyots are unique because of their flattened tops. These structures start as seamounts, but after their tops reach the surface of the ocean, they are eroded away. This erosion gives guyots their characteristic appearance. So far, you have learned about some of the features that result from the actions of plate tectonics. But what about the regions of the ocean where not as much happens? Let's start by going for a swim. The portion of the continent that is underwater is called the continental shelf. When you wade out into the ocean, you are standing on the continental shelf. At the edge of the continental shelf, a sudden increase occurs in the depth. This marks the beginning of the continental slope. Once the rate of descent decreases again, the continental rise begins. Although the name might seem to imply it, the ocean does not become shallower here, but it does not become deeper as quickly either. Finally, at the end of the continental rise is the abyssal plain. This large, flat region is the site of sediment buildup and extends to the underwater ridge or a volcano. Although most of us will only see a small portion of the ocean, it is a fascinating place with many mysteries still awaiting to be discovered.
Thank you for watching. Thank you for watching.